Welcome to qnawire.
The problem is following. We have a light source. The light source have got a wavelength of 540 nanometers, and we have a glass which has got a width of 2.5 millimeter, and that is placed between screen and the source. So we have a glass between source and screen. So here we have a screen. The distance between a source and screen is 1.8 centimeter. The question is asked that how many wavelengths do we have in the distance of 1.8 centimeters from a light source to the screen? How many wavelengths we have? So in order to find wavelengths, the number of wavelengths, by definition, the number of wavelengths is equal to the distance of a material represented by a d divided by the wavelength of a light inside that material, lambda. So we can write the total distance for air and a glass and divide by the wavelength inside that material, and then we will get the total number of wavelengths. So the total number of wavelengths we have here can be written as the distance in air over the wavelength plus the distance in a glass times the refractive index of a glass n over the wavelength lambda in a material. We can write a lambda in a material by this relation. Lambda is equal to in a material is equal to lambda in a vacuum over a refractive index. Then we can find the distance in air also by subtracting the distance of the glass from the total distance. So the total distance we have is 0.018 meter minus the distance of the glass. So the glass distance is 0.0025. If I subtract this, then the distance of a glass I get here is 0.0155 meter. 155 meter. Now I will plug this value distance here and plug the refractive index of a glass, and the distance. Sorry, this is the distance in air. So this is the distance in air. This is the distance in air. So this is the distance in air. So we can plug the distance in air in the formula here, and the distance in a glass is given already here. So if we plug those values and then do the maths, then the number of wavelengths we get here is 3.52 times 10 to the power 4. 10 to the power 4. End of the problem. Thank you for watching.